This is a really exciting topic for us, so I do want to welcome Vincent Geddes. He's going to talk about Snowfork.
Cool. Testing. Okay, cool. Let me start. Hi, everyone. I'm really excited to present Snowbridge today. It's been a long time. Snowbridge is an Ethereum bridge, a decentralized bridge, which we're deploying onto the BridgeHub parachain, the system parachain. A bit about me. I'm the tech lead for Snowbridge. I've been leading the project for several years, together with my co-founder, Aidan. And previously, my background is in virtualization, hypervisors, and cloud infrastructure. I believe Norbert covered BridgeHub in the previous talk, so I'm not going to focus too much on that, but rather about our bridge, which is built on top of BridgeHub. Here's a meme for you. Though seriously, I realize this isn't a laughing matter for many parachain teams here in the audience. So I want to go a bit into why we're in this situation right now, and provide context. So here's a brief history of the project. Back in 2021, as part of a Web3 Foundation grant, we had a first version of our bridge developed. This included light clients for Ethereum proof-of-work consensus, as well as the first prototype version of the Beefy protocol. And we had built a ERC20 token bridge on top of those light clients. Then in 2022, there was this big event in Ethereum land. It was called the Merge. And this is where Ethereum ditched proof of work and it moved over to proof of stake, an entirely new consensus model. This meant we had to throw out our old light client for Ethereum and build a totally new one. We also had to make sure that various Ethereum node implementations actually supported the APIs required by our light client. Support was quite raw and half-baked, like in mid-2022. We also had to substantially alter our Beefy light client, which runs on Ethereum. Even though the Beefy light client verifies consensus on Polkadot, it actually requires some knowledge about consensus on Ethereum. Another big delay in 2022 was figuring out our business model. At this point, we're totally self-funded, and we had to figure out whether we're going to go the VC funding route or the public treasury funding route. So that added a bit of delay while we sorted that out. Then BridgeHub came onto the scene, XCM v3 as well, and we decided to launch on BridgeHub. I think it was a very compelling platform which we wanted to use. We managed to get public treasury funding, but it involved the re-architecture of almost the entire bridge. For example, XCM v3 natively supports exporting messages to foreign consensus systems. So we wanted to use that protocol, that language, instead of our own version of XCM. We also put a lot of thought into decentralized cross-chain governance. It's harder than it seems. And I'll talk more about that in a later slide. Going back to the technical side of the things, I want to emphasize that Snowbridge is a trustless, decentralized, and general-purpose bridge. Time is short, so I won't go into the full definition of these things. For me, Snowbridge is trustless, as users need only trust in the code, cryptography, and economics, and not squishy humans. Decentralized, as there are no centralized multi-sigs which can take control of the bridge. There's no escape hatches, and general purpose, as it supports arbitrary state transfer between Polkadot and Ethereum, upon which anyone can build higher-level applications, such as token transfer, arbitrary cross-chain contract calls, NFTs, and so on. Now I'm going to talk a bit about the architecture very briefly. On the Polkadot side, you've got the BridgeHub parachain. Parachains are connected to it using HRMP channels upon which XCM messages flow. On the Ethereum side, you've got this gateway contract. And this is like a guard contract. It's almost all of the Ethereum side of our bridge is implemented in this gateway contract, almost like a single contract architecture. There's various things called agents on the side. I'll explain them very soon. But the important thing to note is that each parachain has its own independent messaging channel to Ethereum. These channels between the BridgeHub and the gateway. And this unlocks a lot of flexibility when it comes to configuring fees and incentives on a per-channel basis. For example, some parachains may decide to totally subsidize fees for their users. And we don't want that to affect other parachains if they make that choice. There are a few other contracts hidden on the Ethereum side, which wasn't a space, but on. Like there's a beefy light client, and there's various Solidity libraries, which are all linked to the gateway. Agents. There's a picture of an agent from a famous movie in the 90s. Agents are proxy contracts on Ethereum for parachains and nested consensus systems within a parachain. And let's look at a scenario where that'd be useful. A parachain wants to call a contract method on Ethereum. The receiving contract, which doesn't necessarily know about Polkadot or the bridge, needs to somehow authenticate the sender of that call. Agents solve this problem. There are normal contracts with an address, and the receiving contract can just check that address using idiomatic Solidity code. And this allows parachains to call like Uniswap contracts or so on. They don't have to write like any glue layers. Agents are used pervasively throughout our bridge for a number of things, including what I'm about to talk about next. So fees and incentives. A decentralized bridge needs to be kept operational through an economic system involving fees and rewards. The bridge needs to charge fees to users, and it needs to reward off-chain relayers for delivering messages to the other side of the bridge, the destination. And there are a lot of problems to solve here. It's almost a separate project in itself, apart from bridges. These problems include the pricing of individual message transfers on the source chain, where you don't know the cost of dispatch and execution on the destination chain. So it's a situation of incomplete information. There's settlement of dispatch costs on the destination chain. So you've got fees charged on the source chain, but you need to pay for execution on the destination chain and reward the relayers. And obviously incentivizing message relayers to keep the bridge alive, to keep the message transfers going. And finally, user experience. We want something that is easy for users. They only have to send a single transaction to send data across the bridge using a single fee. And there are lots of solutions which one can use here. Like, for example, centralized fee oracles on the source chain. Another solution is a whole decentralized fee market. And that's a whole separate project on its own, which is quite out of scope for the bridge. So we've designed a solution which tries to balance all these problems. And I'm going to explain that next. So the good news for users is that the bridge charges a fee in the source, in the native token of the source network. So on Ethereum, users will be charged a fee in Ether. On Polkadot, users will be charged a fee in DOT on any parachain. The single fee, covers the cost of execution on the destination network. This includes both the static component of execution and the dynamic component. And what I mean by that is the dynamic component would be like XCM transact, where the cost of dispatch is variable. As I said previously, parachains have the flexibility to configure the fee parameters for their channel, for example, allowing them to subsidize the messaging costs on behalf of their users. There's one catch, though. Currently, the governance for each channel is required to periodically rebalance accounts. For example, withdraw the collected fees on Ethereum, exchange for DOT, and deposit on BridgeHub to be used to pay for rewards. And we'll add documentation about that over the coming weeks. So I'm going to touch upon governance. And I want to be very clear here. The gateway on Ethereum is governed entirely by Polkadot OpenGov. There's no multi-sigs on Ethereum, there's no escape hatches. Governance messages flow from the relay chain to BridgeHub and then through the bridge itself to the gateway. In practice, implementing this is actually quite difficult and needs support at all layers of the bridge. It's like decentralized governance is not something you can tack on at the end of a project as you're about to launch. For example, one case, we have to make sure that the Beefy protocol itself is versioned so that the Ethereum side, the gateway, can continue to be upgraded as Beefy consensus evolves. If we don't have that support for versioning, then the gateway on Ethereum is going to die if it can't verify messages which are using a different version of the Beefy protocol. I want to go a bit into the light clients, which are a very important part of our bridge, and it's like where we spend a lot of time developing. On Ethereum, we have a Beefy light client, which verifies messages from parachains, specifically BridgeHub on Polkadot. So the Beefy light client verifies a dynamic subset of randomly chosen validator signatures using a multi-step interactive protocol. So relayers have to submit multiple transactions to Ethereum in like this interactive game, you can say. The randomly chosen validator signatures, those are chosen by the light client. The relay is forced to provide those signatures. That random seed is derived from RANDAR, and this is like a gadget on Ethereum beacon chain, which gathers entropy from block proposers. An important thing about our light clients is that relays can participate permissionlessly. They don't have to put up a deposit. There's no staking or slashing or anything like that. Anyone here can run a Beefy relay. To secure that is a bit tricky. What we actually have to do is force relayers to put up increasingly larger and larger numbers of signatures if they attempt to game the system in a certain way. Finally, I want to make clear that we require Beefy to be activated on Kusama and Polkadot before we can actually deploy. I believe that's scheduled to happen sometime in the next month or two. I don't have the full picture. Then on Ethereum, on BridgeHub, we have an Ethereum light client. And we use this to verify messages from the Ethereum execution layer. The light client progresses by being given updates by relayers about the consensus of the beacon chain. And if you don't know, the beacon chain is like a chain above the Ethereum execution chain. In some ways, it's similar to the Polkadot relay chain. These consensus updates are signed by 512 randomly chosen signatures. This set is known as the sync committee. And the sync committee changes every epoch, which is around 27 hours. Now, verifying that many Beeler signatures is actually quite expensive, both in terms of storage costs, so it can bloat up the POV of a BridgeHub parachain block, as well as weight. So a lot of thought went into optimizing that carefully. I do want to focus on a general concern about the security of the protocol upon which our light client depends on. And I'm talking here about the Altair sync protocol. This is a protocol which all light clients have to rely on in order to have a light client for Ethereum. We've analyzed the problem from multiple angles, and we believe an attack is highly improbable. We wrote up a report which you can access at this QR code. Please go and read it, add comments. I'd love to see more discussion on that thread in the Polkadot forum. From there, you also find a link to a report from the Torn team. And they came up with a very similar analysis that an attack is highly improbable. They also gave like one solution, which is to increase the number of signatures to be verified, like 70% instead of 66%. So yeah, please go and read that. Now jumping up to the user application layer, we're going to launch initially with a ERC20 token bridge. This is about transferring ERC20 tokens on Ethereum to AssetHub and back again. So on Ethereum, ERC20 tokens can be registered permissionlessly by anyone. All they have to do is put up a fairly large deposit. Probably make it like 0.5 Ether or 1 Ether, haven't decided. That's to prevent spamming and registration, or minimize spamming and registration of malicious tokens. As I said, the wrapped tokens are minted on AssetHub. So AssetHub will be the reserve location of these tokens. And from AssetHub, the tokens can be deposited into a final destination parachain using a reserve transfer. And our APIs on Ethereum allow that all of this to be done in a single step. So users only need to send a single transaction to the gateway, and that results in tokens being minted on AssetHub and then reserve transferred to the final destination parachain. What else? We support sending to both 32-byte and 20-byte destination accounts. So, for example, like a Moonbeam account, which is 20 bytes, can receive tokens, and any other parachains which happen to use those. And over time, we'll probably support more different account variants. I know XCM multi-location support a few more, but right now we're just keeping the API very simple. Status today. So finally, we've got ERC20 transfers between Rococo and the Gurley testnet. We'll probably open this up to the general public in the coming weeks, maybe 2 or 3 weeks. We're still doing some more internal testing. So our code's been audited. We've had several audits, actually, or 2. And those reports are now undergoing a QA process, and we can expect to publish them sometime in October and November. We're working on a few issues uncovered in those audits, but they're fairly straightforward fixes, and they're not going to impact our timeline substantially. Oh, I did give an update on the Polkadot forum last week, and I went into a bit more detail about the issues in the audit. So if you want to probe, please read our Polkadot forum. So I think everyone wants to know when we're launching Kusama and Polkadot. I think we're going to be in a position to deploy on Kusama this year once Beefy has been activated, and then Kusama sometime after that. There are a few tasks remaining here. Apart from Beefy support, we need to merge some of our code into the upstream Polkadot SDK repo. This is because our bridge is effectively a system or community bridge now. There's the Polkadot SDK repo actually has a bridges subdirectory now, so we're going to add our code there. And importantly, we also want to run a bug bounty program on either Rococo or Kusama. We haven't decided that yet. But this is like a an additional security measure beyond audits, which we think is very important. Then there's like several features which we have been working on, but we're not going to deploy into our mainline branch right now. Adding support for arbitrary contract calls between Polkadot parachains and Ethereum, also known as Transact. And then, yeah, many parachains of tokens, which I'm sure they'd like to bridge to other foreign consensus systems, such as Ethereum. So that'll be supported as well. And that's going to reuse some of our existing APIs for sending ERC20 tokens to Polkadot. So reuse some of the same user interface. Oh, oopsie. I know we're a bit under time. I was scared I was going to go over time, so 5 minutes early. Please visit those links there if you want to read more, and I'm open to questions. Just be aware my hearing is not that great, so. Yeah. Thanks.
Hello.
Hey, hi there.
Hey, thank you. So what do you expect is a reasonable cadence or frequency of communication between the parachain and the agent? Like how often would they transact messages? And have you any insight into the operational cost, basically the gas fees on the Ethereum side?
Okay. By gas costs for users or relays who are updating consensus for our light clients?
Maybe from the perspective of the parachain who is paying for the gas.
Yeah. Okay, I'll give a breakdown of the gas costs involved. So in Ethereum, we've got a beefy light client, and the relay sends a message to the beefy light client that involves verifying a bunch of Merkle trees. I think there's like 3 different Merkle trees which have to be verified. And so that's quite a large component of the gas costs. I think that's, last time I checked, it's like 100,000 gas for that, verifying those proofs. And then I guess above that is just the gas cost of the transact itself, which is up to the parachain. Yeah. Your previous question was about
how often would the parachain and the agent communicate?
Oh, right, okay. Yeah, let me go a bit into that. So parachains and nested consensus systems first have to spawn an agent on Ethereum. So there's like a permissionless API on BridgeHub, which they can call, and that will end up spawning an agent on Ethereum. And after that, parachains won't communicate directly with agents. All those interactions are governed by the bridge. So it'll only communicate indirectly through the agent through the various glue layers of our bridge. So for example, when a parachain wants to call an Ethereum contract, that call will be forwarded to the agent. And then in Solidity, there's this opcode called delegate call. And that call will be dispatched from the context of the agent to the final destination contract. And that's the only touch point between the parachain and the agent. But when it comes to asset transfer, okay, let's say a parachain wants to transfer its tokens to Ethereum, its own native tokens, like a Moonbeam token or a Color token. What will happen there is the synthetic or wrapped Moonbeam token will belong to the agent. So the agent will have control over that token and control minting and burning of that asset. That's another touch point. Yeah. Cool. Sure. Any other questions?
So we've talked about the cost to the users. But what about the cost of Ethereum verifying every single block? I mean, the validity of the header of every single block in Polkadot. How expensive is that? Is it really going to be verifying every single header? I guess so.
We're not actually verifying headers in our Beefy Lite client. What the Beefy Lite client on Ethereum actually verifies what we call MMR routes, Miracle Mountain Range. And these routes are signed by Beefy validators. So that's the only thing we're verifying, those signatures.
Yeah, for every block in Polkadot.
Yeah. But as I said, it's only like a random subset. So even though Polkadot may have 1,000 Beefy validators, we'll be verifying a smaller subset, less than somewhere between 20 to 40 signatures, depending on our dynamic algorithm. Cool. Oh, okay, great. Cool. Thanks, everyone, for listening. Cool.